In this video, we're going to talk about pairs of lines and also pairs of angles that occur when lines intersect. First, let's look at parallel lines. These are lines that are in the same plane, so they're coplanar, and they are always the same distance apart. This means these lines never meet. You can think of like the rails on a railroad track that keep going the same distance apart and they're never going to meet. Those are parallel lines. Now, when we draw a diagram for parallel lines, we'll have two lines that are parallel. And to show that they're parallel, we use, similar to the tick marks we use for congruence, we use little arrows to show that these two lines are parallel. So if we see a diagram with little arrows on the lines, that's how we know that those lines are parallel. Now let's say this is line AB, I'll draw on those points there, and this is line CD. And maybe I want to write about these lines being parallel. Well, I can write my line AB, remember, with the line with the arrows on top, and the line CD, and then to show that they're parallel, I use two diagonal lines. These two diagonal slashes mean that line AB is parallel to line CD. The next type of lines are perpendicular lines. These are lines that meet at a right angle. So for this you can think of like an intersection of roads where the roads meet and make perfect corners. Now we can draw perpendicular lines, and the way we show that these two lines are perpendicular is create that right angle box in the corner. That right angle box in the corner where those lines intersect tells us that they meet at a right angle, which means they're perpendicular. Now let's say again this is line AB and this is line CD, and this time I want to write about these two lines being perpendicular. I can write line AB and also line CD. And to show that they're perpendicular, I have a vertical line with a horizontal line at the bottom. That kind of makes a right angle with those two lines. That is how I show that two lines are perpendicular. So this little cross right here tells me line AB is perpendicular to line CD. The last set of lines that we're going to look at are called skew lines. Like parallel lines, these lines also never meet. But what makes them different from parallel lines is that they are not on the same plane. They are non-coplanar. Because they're not on the same plane, they can be lines that don't meet but are not parallel. So let's take a look at this picture of street signs and the lines drawn on them. You can see we've got these two lines of these street signs, and one line is completely above the other one, and so because of that, these lines are never going to meet. But there's no way we could draw a plane that would fit both of these lines. That makes these lines non-coplanar. That's why these lines are skew lines. We can see the same thing here in this diagram below. We've got two lines that are on two different planes, one above the other. So these lines aren't going to meet. But they also aren't parallel because they don't run in the same direction. So these lines are skew lines. Now we're going to switch gears a little bit and talk about angle pairs that get formed when lines intersect. But first we need to learn a new word. What is a transversal? A transversal is just a line that crosses at least two other lines. So in this diagram, this line, this diagonal line that crosses line L and line M, line T, that is the transversal. So you can see we have 8 different angles that get formed when the transversal line T crosses lines L and M. And we'll put these in 2 different groups. Some of these angles are interior angles and some are exterior angles. But how do we tell the difference? Let's think about line L and line M as being like the walls of a house. So I've got this house, this box in blue that I've drawn in, with L and M as 2 of the walls. Well, I can see angle 3, angle 4, angle 5, and angle 6 are all on the inside or the interior of my house. Those are what we call interior angles. The rest of my angles, angle 1, angle 2, angle 7, and angle 8, those are all outside the house. Those are on the exterior of the house. So we call those exterior angles. Okay, so using what we just learned about transversals and about interior and exterior angles, let's start talking about special angle pairs. We've already talked about vertical angles and linear pairs, but let's look at them for review. Remember, vertical angles are just angles on opposite sides of intersecting lines. So I've got angle 2 and angle 3, or angle 1 and angle 4. Both of those are vertical angle pairs. I could also use 5 and 8 or 6 and 7. Those are all vertical angle pairs. We've also talked about linear pairs. Those are two adjacent angles, angles that are next to each other, that form a straight line. So we could talk about angle 1 and angle 2, or angle 3 and angle 4. We could also use angle 5 and angle 6, or angle 7 and angle 8. Those are all linear pairs. Now we're going to start talking about new angle pairs that we haven't looked at before. The first angle pair is alternate interior angles. And like the name says, they are going to be two interior angles, but these are on opposite sides of the transversal. That's why we see the word alternate in the name. Alternate, opposite sides. So these would be angles like 4 and 5. Angle 4 and angle 5 form an alternate interior angle pair. Or we could also use angle 3 and angle 6. Those are both interior angles. Remember, they're on the inside of that house that we can form, but they are on opposite sides of the transversal. The next pair of angles are called alternate exterior angles. These are exterior angles, and they are on opposite sides of the transversal. Remember, that word alternate tells us it's on opposite sides of the transversal. So examples of this would be angle 2 and angle 7. And also angle 1 and angle 8. So you can see both of those pairs, they're all on the outside of that house we can form. And they are also on opposite sides of that transversal that we've got through there. Okay, here are the last three pairs of angles. The first is same side interior angles. And just like the name says, they are interior angles that are on the same side of the transversal. So, inside our house, on the same side of the transversal, I've got angle 4 and angle 6. And also, inside, on the same side of our transversal, I've got angle 3 and angle 5. Now let's look at same side exterior angles. Again, you can probably guess what these are. They're exterior angles that are on the same side of the transversal. So outside my house this time, I've got angle 2 and angle 8 on the same side of my transversal. And then I've also got angle 1 and angle 7 also on the same side of my transversal. My last pair of angles are called corresponding angles. These are kind of angles that are like in the same position. We can talk about it a little more technically by calling them two angles on the same side of the transversal, where one is interior and one is exterior. But we can think about it as them being in the same position. So, for example, angle 2 and angle 6, those are both kind of the top right corner of my intersection. But you notice they're the same side of the transversal. One is interior and one is exterior. Another example would be angle 4 and angle 8. You can see they're both like bottom right side of my intersections, both on the same side of the transversal, one interior, one exterior. I've also got angle 1 and angle 5. Those are corresponding angles. And finally, I have angle 3 and angle 7. Those are both corresponding angles as well. So I know we've got a lot of new math words to learn today, but it's going to be really important that we become comfortable with them because pretty soon we're going to be using them to solve for missing angles and writing equations involving these.